All right, example 11-1 is the mother of all factor of change problems. We've got a figure skater, as we talked about in class, going from a high rotational inertia and a low angular speed to a lower rotational inertia and a higher angular speed. So here's the information we have. We have the initial angular speed is 1.50 radians per second. We have the final as 15 radians per second. So you notice that it's increased by a factor of 10. So I'm going to write this, omega final equals 10 omega old. Well, I know I'm mixing initial and final and old and new, but you get the point. So the question is, how does the rotational inertia change and how does the kinetic energy change? So in this situation, there's no external torque on the system, so we can say the initial angular momentum is equal to the final angular momentum. So the initial angular momentum is I initial, omega initial. The final angular momentum is rotational inertia final, angular speed final. Okay, so to find our ratio IF to I initial, the new to the old, right? The new to the old. We just do some fancy algebra and we get initial omega over final omega, and we know that we have an initial omega over 10 initial omega. This is kind of a different way of having the factor of change problem, but if you're familiar with these, you should get the gist here. So we have 0.100, all right? The new rotational inertia is 0.100 of the old rotational inertia. And so you knew that would happen, right? If the angular speed goes up, the rotational inertia has to go down. Or you could say you could say when the skater pulls her arms in, her rotational inertia decreases and therefore her angular speed increases. Anyway, this is our new moment of inertia for the skater with her arms in. Well, part B says, how does the kinetic energy change? So our new kinetic energy is our 1/2, I guess we didn't do it this way. K is equal to 1/2 I omega squared. So my new kinetic energy, I put a 1 for the 1/2 because that's not changing. The new I is 0.10 or 1/10, however you like. The new angular speed is 10 times the old one. So I've got to put a 10 here. This is the first time we've had any factor that's not 2 or 3 or 4. This is 10th and 1/10. But then remember, I need to square this. So what I get is 10. So the new kinetic energy is 10 times the old kinetic energy. So if you want to do that problem again a different way, kind of the way we did it before, you certainly can do that. But that shows us how the angular momentum stays the same and what changes.